For triaxial test, consolidation and drain test, CU test, also known as CIU. So this is for the data analysis, how we will analyze the data from the consolidated and drain triaxial test. So this is an example. So the data from the CU triaxial test, as you can see here, that we have the cell pressure sigma 3 and also we have the sigma D, the deviated stress at failure. And also recorded from the CU triaxial test is the U, which is the pore pressure at failure. So this is the difference with the consolidated drain. In the consolidated drain or CD test, so we don't have any U recorded at the end of the experiment. However, in this consolidated and drain triaxial test, you will have the value of pore water pressure. So now look at the question. Okay, you need to plot the Mohr circle for all specimens based on the total stress analysis and effective stress analysis. Again, alright, for the consolidation and drain triaxial test from the CU test, you can have the data for the total and also for the effective stress analysis because you have the U value. So this is the sigma, this is the sigma prime, which is sigma minus U. So you can have the analysis based on the total stress analysis and also based on the effective stress analysis. So you need to draw the failure envelope for both analysis and also determine the total shear strength and effective shear strength. Alright, so for this first video of the analysis from the CU triaxial test, we will answer question Roman number 1, 2 and 3. For the total stress analysis, okay, for the total stress analysis, in order to plot the Mohr circle, okay, in order to plot the Mohr circle, you need to have the sigma 3 and sigma 1. Okay, so since in this question already give you the sigma 3 value and then also give you the deviated stress, so you can simply get the sigma 1 by using this equation, which is the sigma 1 is equivalent to sigma 3 plus sigma D. So you will have the value for the sigma 1. Now once you have the sigma 1 and sigma 3, you can simply plot the graph for the total stress analysis. Okay, so for the total stress analysis, what you need to have is sigma 3 and sigma 1. Okay, so make sure you have the y-axis and x-axis. Again and again, the scale for x-axis and y-axis, the similar scale, right? And then you can plot your first Mohr circle. As you can see here that the sigma 3 prime was stated at 150, value at the 150 here. This is 150 kPa. And the sigma 1 prime is at 342. So how to plot this? As similar as in CD test, that you need to know the center of the circle. However, here we know that the diameter of this circle is the sigma D, which is, for example, here is 192. So in order to get the radius, you just need to divide the sigma D by 2. So you will have the radius of the circle, right? And then you need to plot all the Mohr circle for all 3 specimens. So this is for the total stress analysis. Alright, and then after that, as usual, you need to have the failure envelope. Alright, the failure envelope that tangent to the all Mohr circles. Minimum interceptions between the failure envelope and the y-axis is at 0. So you will have that C value will equivalent to 0 kPa. And don't forget to measure the angle of friction using the protector. So you will have the angle of friction is 23 degree. Okay, so this is for the total stress analysis. Straightforward, you just use the sigma 3 given in the question and then get the sigma 1 from the deviated stress given in the question. Now, for the effective stress analysis, Alright, so for the effective stress analysis, knowing that sigma prime equivalent to sigma minus u, so in this solution, we need to consider the presence of pore water pressure. So as you can see here, in order to plot the effective stress analysis, what you need to have are the sigma 3 prime and sigma 1 prime. So now you have the sigma 3 here. How to get the sigma 3 prime is simply sigma 3 minus u. Right, as stated here. So you will have this value of sigma 3 prime. And then for sigma 1 prime, again you need to have the sigma 1 first. Then you minus with the u. You will have the sigma 1 prime. So this is the sigma 1 prime. Once you have the sigma 3 prime and sigma 1 prime, you can plot the value. Alright, so again, in order to plot the Mohr circle, so for this effective stress analysis, you must use the sigma 3 prime and sigma 1 prime. So this is how it look like. You can see here that sigma 3 prime, for example, here is 880, it's around here. And then it will end at 272, it's around here. So you need to plot all the specimen, and then don't forget to have the failure envelope. Alright, so this is the failure envelope. Okay, again the C was intercept at equal to 0, and the angle of friction is 33 degrees.